right, we are graphing. Method number 3, the trilogy, if you will. We're talking about graphing via the slope-intercept method. The slope-intercept is this right here, mx plus b, where this is the slope, which is rise over run. Remember that, rise over run. That's how far up and down you go, divided by how far left and right you go. This is the y-axis intercept, the y-axis intercept. So if I start off here, and let's say that I had to do something like y equals 6x minus 1, okay? 6x minus 1, and I want to use this method of using the information in this formula here. The minus 1, I'll circle that, that is going to be the y-axis intercept. So my first move is to go down 1 and put a dot right there. All right, so that's my dot at 1. And then what I do is I figure out the slope. I only need 2 points, and that's one of them right there. This thing right here, whatever that is, tells you where to put the first dot. The first dot is on the y-axis, always, always, always. The second thing you do is figure out what your slope is, and if it's a positive number like that, it's just 6 over 1. So now, here's where this is goofed up constantly. You count up 6 from this dot, not from the origin, from this dot. So you go 1, 2, 3, 4, 5, 6, and over 1. Okay, if it's positive, you go up and right. If it's negative, you go down and right. Okay, so, and then we'll just connect a line through this, something like that right there. Okay, so that would be our graph. It's very fast. You don't have to do a lot of math to do it if you can just identify what these things are. So let's try another one. Let's try another one. Okay, let's say we had something, and I'll make this interesting. Let's make a 2x minus, let's say 3y equals 6. Now here's one in standard form, and we're going to graph this. Now the slope-intercept method is a little slower here because you have to put it in slope-intercept method. So with these two examples, I want to cover all the bases here. When you have something like this, you have to solve it for y. So solve for y first. Okay, that's the first step you do. So we got to do that correctly. So we're going to subtract 2x. This would be negative 3y equals negative 2x plus 6. And then we'll divide everything by this negative 3. And I do mean everything. So that's all divided by that negative 3, so that cancels right there. That is going to cancel right there. Equal signs are lined up. This looks good. Y equals, that will become positive 2/3 x minus 2. That reduces to 2. Now we have it. This is in slope-intercept method. So this is going to be my y-axis intercept. So I'm going to come down 2. Remember, if that was plus 2, I would be going up 2 for my first dot. My slope is a fraction this time. So this is rise over run right there. So I go up 2 from here. From right here, I go 1. Okay, don't count the one you're on. That's another absolute rookie mistake. Don't go 1, 2. It's 1, 2, and then over 3. 1, 2, 3. And that dot would be right there. And this line would go through there like that. Okay, hitting that. When you make your arrows, make sure you put a little bit of length on them so that you can see where they're going. Okay, that's basically it for the slope-intercept method. However, let me take this opportunity to talk about special cases real fast. If you have something like, so we'll call this special cases, because I didn't video this yet, but I want to show you too. Let's say we have a line of the form y equals a number like negative 3, and we'll change color here so we can see them both. Let's say x equals -3, and I'll show you the difference. First, the yellow one. If it's of the form y equals a number, it's a flat line. Okay, so it's going to be a flat line that goes right through here like that. That's going to be y equals -3, except I went the wrong way. It should be down 3 right here, like so. That's y equals -3. X equals -3 would be a vertical line, 1, 2, 3, passing through the x-axis like that, right there. It's pretty straight, isn't it? X equals -3. And the slope is important to talk about. I won't get into the slope formula yet, but if you pick 2 points on this yellow line and use y minus or y2 minus y1 over x2 minus x1, you will see that the slope of the yellow line is 0. Let me write that on here. Slope equals 0 because it's flat. But on this one, if I'd use the slope formula, which this is m equals, you would get a slope that is equal to something that's undefined. Okay, so vertical lines have an undefined slope. A flat line has a slope equal to 0. All right, that's it. Covered all the bases there, I hope, with the slope-intercept method of graphing. Go back and check that out again. And with the special cases, have a good one.